The modern jetliner is one of the most complex machines ever built. It represents a culmination of years of design and research, the cutting edge of engineering and technology, and a corporate gamble of epic proportions.
This is a big bet industry. You have to have an appetite for risk that makes it exciting. Getting it done is the hard thing.
It takes the best mind, it takes the most skilled workman anywhere, and it takes more money than you ever imagined.
When you're building a new aircraft, it's a really huge undertaking, and it's so much is riding on it. The company's whole future is at stake.
A new plane is both an extraordinarily exciting event and a really frightening event. It's big. Today's dollars, brand new airplane, the number could be 20, 25 billion dollars. Billion with a B.
We make huge bets on commercial airplanes where you have to invest a significant amount of money up front before recovering a dime. You have to make sure you have the right product and that you have customers that are going to pay for it. You know, all of that takes place before you sell an airplane. And so the thing that you have to do and be to be successful in that business is to be right.
Determining how and when to launch a new airplane and which new technologies to include is one of the great challenges of the aerospace business. Mistakes like building the wrong plane or no new plane at all can doom a company. Most of the legendary names in aviation are no longer in the business of making commercial aircraft. Companies like de Havilland, Fokker, Douglas, and Lockheed.
And that tells you something about the sort of Darwinian progress of this aerospace business. If you made the wrong bet, as some of those companies did, you spent billions of dollars on the wrong airplane, you go out of business.
Today, the enterprise of developing and building these incredibly complex and expensive machines is dominated by just two companies, Boeing and Airbus.
There is nothing like the competition between Airbus and Boeing. I mean, Airbus and Boeing have been challenging each other now for the last 20 years, outdoing each other, pushing the envelope further and further.
And for both companies, the stakes are never higher than when they make the decision to build an all-new airplane. In 2000, Boeing was at just such a moment. Airbus had announced it would build the biggest passenger jet ever, the A380, a double-decker that could seat up to 850 people.
It's Airbus that's betting that, gosh, if you can build an airplane that can carry ultimately maybe as many as 800 people, that's the way to make money.
And the A380 was a direct challenge to perhaps the most iconic plane Boeing had ever built, the 747. It was the world's first jumbo jet, and since its first flight in 1969, there had been no bigger passenger jet in the sky.
This was a market that Boeing had created absolutely themselves, and that they had owned this market. And then the fact that Airbus was coming along and taking that market away from them, and not only taking it away from them, but demonstrating that they too could build a state-of-the-art large aircraft which would be very appealing to the airlines. That really annoyed Boeing.
Boeing had a decision to make. What plane, if any, to build to compete with Airbus?
We set aside a small team and literally locked them up in a room and said, we need you to start thinking about a brand new airplane.
We got to understand that.
There's a lot of stuff that goes on
to try to understand it. You know, is it fuel burn that's more important? Is it pilot salaries that are more important? Is it maintenance costs that are more important? You know, what's the right balance of the economic factors of an airplane that will make it successful?
Any successful airplane has to balance the airline's economic concerns against the passenger's travel experience. For decades, airlines have been moving large numbers of people between the world's major aviation centers. Travelers arriving at these hubs, places like New York and London, transfer to smaller planes that then take them to their final destination. But Boeing's research showed that passengers, and now airlines, were looking for a plane that could economically carry people over great distances directly to their final destination without passing through a hub.
You know, the last thing you want to do is stop in a city where you don't want to stop. One, that stop adds time to the trip. Two, it almost guarantees your luggage doesn't show up with you. And there's a reasonable chance that you won't get to the final destination when you thought you would as well. So that forces us to do things like, well, how can we make airplanes smaller but have the same capabilities as a larger airplane?
Airbus had bet on size with the A380, which travels from hub to hub. But Boeing saw a market that was ready for a smaller, faster plane that could travel non-stop to its final destination. Boeing called it the Sonic Cruiser.
So there was this really enthusiastic group of engineers at Boeing that were working on the Sonic Cruiser, you know, like their life depended on it. It was the coolest thing at Boeing.
It would be a dramatic departure from the design of existing commercial jets. It would have a delta wing, rear-mounted engines, two small canards near the front, and a fuselage made of a synthetic material, not metal. Built for speed, it would fly just below the speed of sound.
Airbus was building the really big airplane, and we were building the really fast airplane. They zigged, we zagged. That's a difference there, you know, and we're going to see, you know, which strategy will work best.
The shape of the Sonic Cruiser was like virtually nothing that had been seen before. It was a thing of beauty.
It just caught everybody's imagination. And what the airlines were looking at were two things. One is the 20% faster gave the passenger what they wanted, right? You get someplace quicker. The other thing was the airplane flies 20% faster. In theory, you should need 20% less of them.
But speed comes at a price. Boeing's previous attempt in the 1960s to make speed a priority was its supersonic transport, or SST. Few planes have ever generated more excitement in the aviation world.
The revolutionary design, the most amazing aeroplane, swing wing, 4 huge engines, 300 passengers, 2.5 times the speed of sound.
But the supersonic transport never went beyond a full-scale mock-up.
The problem is that once you nudge the speed up to that level, it becomes a gas guzzler. There's nothing you can do about it.
And one consistent concern of every airline is the cost of fuel.
Fuel efficiency has assumed ever more importance over the last 40 years. It's not just the fact that fuel costs higher, but it's the fact that it's so variable that constitutes a huge risk to the airlines. You just can't foresee exactly what's going to happen. There are so-called black swan events all the time.
This just in, you were looking at World Trade Center, and we have unconfirmed reports this morning that a plane carried
at altitude over New York City, and it appeared to crest directly in the middle of one of the World Trade Center towers.
The day after the 9/11 tragedy, there was a meeting in Seattle for aerospace professionals. Everybody was shell-shocked by the events of the previous day, but there was almost a recognition that the supersonic era was suddenly over with, and we were looking at a much more austere future.
Late this afternoon, American Airlines cuts 20,000 jobs as the nation all but stops flying.
Delta reports most of its planes are going out 2/3 empty, with people still basically afraid to fly.
After 9/11, everything changed. Security was an issue. Price of oil went through the roof. Our customers told us they wanted an airplane that went long range, burned much less fuel, and for all of that, they'd be willing to sacrifice all the performance we had, the speed, and some of the other things.
Essentially, the airline said, oh, rats. I love the idea of going faster. We'll take the one that burns less fuel, operates more economically, because their customer is price sensitive.
So, although it was a sad kind of acknowledgement, really, of the realities of life, Boeing got on with it. You know, hey, the market's spoken. We know what they want. Let's go and do it.
Boeing would not bet on speed or size. They saw a market for a super-efficient, mid-sized passenger jet. Boeing would call its new plane the 787 Dreamliner. The plane they envisioned could seat as many as 335 passengers. It would travel at conventional speeds, but it would incorporate many of the advanced technologies intended for the sonic cruiser.
The boldness of the entire vision was almost jumping ahead 2 generations in aircraft design. You don't do that easily. You have to change everything.
What would set this new plane apart from every commercial jet that had preceded it would be the very material used to construct it. It would be a transformation that mirrored another radical change in aviation almost 70 years earlier. In 1933, Boeing debuted the all-metal Model 247, the world's first modern airliner. The wood and canvas that most planes had been made of since the first days of aviation became a thing of the past. Boeing's 787 Dreamliner would not be made out of metal, but out of fiber-reinforced plastic. It is an advanced variation of composite, the kind of material commonly used in small consumer products, such as tennis rackets and bike helmets. It's made of lightweight carbon fibers, fabricated into thin layers and infused with a glue. The combination is much stronger than either ingredient on its own, 10 times stronger than its weight in steel.
It's the biggest change ever in the history of commercial aviation, by far.
But before the designers and engineers in Seattle could begin the multi-year effort to build such a revolutionary aircraft, the Boeing Company had to figure out how to pay for it. The cost of research and development to design and build the 787 was initially estimated to be in excess of $10 billion, an investment Boeing would have to make or forfeit its leadership position in commercial aviation to Airbus. Boeing's decision was to seek strategic partners in an effort to cut its research and development costs by as much as 40%.
If one company is responsible for doing all the engineering and doing all of that testing and all of that work, it's a huge bill to pay. But if you can spread out that cost to multiple suppliers who share in the risk, you could do it cheaper, and maybe you could even do it better than one company doing it by itself.
What was new with the 787 was outsourcing not just production, but R&D, the actual expense of creating a new plane. Basically say, this is an idea of what we're looking for that needs to fit in here, go design it for us.
So in the past, we would have footed the entire engineering bill, but we decided that we wanted our supply chain to pay for some of the engineering so that we didn't have as big a bill.
Companies around the world were chosen to engineer and manufacture large sections, including the nose from Spirit in Wichita, Kansas, center fuselages from Alenia in Italy, forward fuselages and wings from Mitsubishi and Kawasaki in Japan. These partners would take on the responsibility and expense of designing the sections and creating new tools, facilities, and production processes. The most ambitious innovation Boeing and its partners introduced was the process of spooling long strips of carbon fiber onto what are essentially enormous robotic tape dispensers that lay the material down in precise, complex patterns. It takes the shape of specific parts, like a wing or a fuselage, and then the huge sections are transferred into a massive sealed chamber called an autoclave, where they are hardened under heat and pressure.
If you think about a fuselage barrel in a plane like a 787, there's as many as 9 people sitting across in a row. So it's a pretty wide object. Imagine that I have to cure it under heat and pressure. It's like, what I described that. Imagine putting an airplane in an oven.
Out of these giant autoclaves come pre-built sections of the plane that once would have required hundreds of aluminum sheets, tens of thousands of rivets, and countless man-hours to assemble.
If you look at the way we built the 707 back in the 50s, and you look at the way we build the 787, it is amazingly different. It is off the charts different.
Boeing's strategy of giving companies around the world a stake in the 787 promised to lower Boeing's costs, but also to help sell the plane.
Countries desperately want to grow economic opportunity. The developing world, which is going to see most of the growth in aviation going forward, wants opportunity. They want to participate in the economic growth that aviation and aerospace enable.
One of the things they're asking for is, we're going to spend all these US dollars on your aeroplane. We want some work for our people.
The strategy worked. Japan was the first foreign country to build the wing of a Boeing plane, and the first to place orders for a Dreamliner. In April 2004, the Japanese airline All Nippon Airways, ANA, committed to buy 50.
I was on the sales side when we came out with the 787, and the promise of the 787 was pretty darn phenomenal. So it was exciting to be in the marketplace selling the airplane because everybody wanted it.
The combination of global partnerships and a deep understanding of what airlines wanted appeared to be working.
It's clear they made a fantastic assessment of the market before the plane had ever been built. And that's because they spent several years talking to their customers, asking them, what's important to you? And then shelving the ideas they had beforehand that didn't fit that description, and finally deciding, this is the plane that has a market, and this is what we'll build.
Airlines were promised the new planes would be ready beginning in 2008, but Boeing was selling a design and not a finished airliner. Boeing had record orders for its Dreamliner, 300 planes valued at over $42 billion. But it had fewer than 3 years to deliver an actual plane, and many questions remained, including how the enormous parts from all over the world would come together. For years, Boeing has had whole sections of its 737 built in Kansas and sent by train to the main assembly facility in Washington State. But parts of the 787 were coming across oceans and from 4 different continents.
There's actually a guy that I worked with who said, well, we're either going to ship that over in giant ships and we're going to have to build a harbor right next to the factory and get it somehow into there, or we could just fly it in. We've got a 747, why not rework the 747 so that it can fly other airplanes inside of it? Which is the most incredible and ostentatious idea.
4 of these customized 747s, called Dreamlifters, with their enlarged bodies and swing tail, circle the globe, picking up the tails, fuselage sections, nose sections, and wings, delivering these parts to assembly facilities in the United States, one in Everett, Washington, and a second built in Charleston, South Carolina. Other large parts, such as engines and landing gear, arrive by land and sea.
The parts come together already pre-stuffed with all of the systems and the wiring, and with these sections arriving, you think, boy, that's astonishing. There's so much in there.
You've got 3, maybe 4 million parts coming from countries across the globe.
Boeing's vision was they were going to be the assembler, the system integrator, pulling in parts from this global network of suppliers, and that Boeing would be able to, quote, snap together a 787 in 3 days.
This was without doubt the biggest challenge any aerospace manufacturer has ever undertaken.
Boeing had good reason to believe it could succeed. During World War II, airplane parts from all over the country were assembled under extreme deadline pressure into the most complex machine that had ever been built, the B-29 bomber. And during the Cold War, Boeing coordinated the work of Project Apollo's many contractors who were building the rocket and spacecraft that took the first humans to the moon. And over the last decade, Boeing has managed the assembly of the International Space Station, built by 16 different countries and put together while in orbit around the Earth.
Large systems integration is our unique advantage. Not many other companies in the world can take all of these technologies and put it into a system that performs safely and at the performance requirements that had been promised originally and can be replicated at high volumes. That's the hard part.
With a supply chain that was truly global, with far more responsibility in the hands of their suppliers than ever before, with untried methods of manufacturing, and a suite of new technologies on board, problems building the 787 were almost inevitable.
One in aerospace should only pick on so many different challenges. Today, I think they look back and say, oh my God, I can't believe we did as many different things to this aircraft.
Executing a project of such complexity proved to be more than some suppliers could handle. Wrinkles were found in the composite skins from one supplier. Fasteners were incorrectly secured on sections of the tail. There were gaps between units that were supposed to fit tightly together, and some sections arrived at the assembly facility unfinished.
We had our partners, and then they had partners who had partners, and the different cultures and the communication was very challenging and added a lot of complexity.
Boeing began to realize that they'd bitten off more than they could chew.
And it was not just the suppliers who were struggling. Just days before the scheduled first flight of the 787, Boeing discovered a flaw in its own design. Higher than expected stress, where the wing joined the fuselage, would force redesign work and further delays.
And with a tightly packed schedule that was absolutely delicate, once you get one disruption, it starts to cascade. So you had this chaos building.
The company's strategy to better manage the enormous expense of new airplane development was failing, and the Dreamliner was still far from a viable airplane.
Boeing had a combination of factors that was turning into a tidal wave that essentially overwhelmed the factory, and that's when the train came off the track at that point.
Boeing shares are down a quarter, the third delay of the Boeing 787
pushed back the schedule for the fourth time.
By the end of 2007, Boeing was facing delays, penalties, and damage to its reputation.
Now Boeing has to tell its 51 customers it won't be ready before the end of next year. Launch airline ANA, for one, is furious.
The most painful thing I think I've ever had to do was to go tell them that we were going to be late. To have to do that multiple times was very, very difficult.
We are the systems integrator. We have to be the ones responsible for delivery, quality, cost, and we lost control of that.
One of the mistakes that Boeing made clearly was that they trusted their supply chain too much.
I've talked to Boeing engineers who told me we didn't even realize what we knew. There were things we just took for granted, and then we realized these partners don't actually know that. They don't know how to do it. They don't have the experience.
That was true even for longtime Boeing suppliers like Mitsubishi, which was building the wing for the 787.
Boeing actually built the first wing in Seattle, and they brought the Japanese in and showed them how to do it and said, okay, go back to Tokyo and build it that way. But making that wing, it's not just building the pieces and putting them together, it's putting the systems into the wing and handling a whole supply chain around that. It was something, even Mitsubishi, a very, very competent manufacturer in its own right, had never actually done that before. So they ran into problems. Of course they ran into problems.
Soon the Dreamliner was on a path to being 3 years behind schedule, an unprecedented delay in Boeing's history. And Ray Connor was tasked with leading a team to fix the supply chain problems.
The perseverance of that team was phenomenal, and of our supplier team too. We started over. I mean, everything had to get reworked, everything.
Boeing solved the problem by throwing people at it and sending hundreds of engineers to Italy, South Carolina, Kansas, and to Japan.
We learned we can't just say, you're our partner, figure it out yourself.
Kathy Moody was one of hundreds of Boeing employees dispatched to supplier locations. She moved to Grottaglie, Italy to help Alenia, the manufacturer of the center fuselage, meet the requirements and deadlines.
Whatever they need. If they need me to help lead, if they need me to help get them some engineering help, there's always that balance between doing the work for them, but then also showing them how to do the work.
In the case of 2 suppliers in South Carolina, the intervention became permanent. Boeing purchased them for a cost of more than $1 billion.
So they ended up having to buy out their suppliers, which weren't doing the work the way they'd expected. And over time, they brought control of the whole process. So I think that they learned a big and expensive lesson.
By the end of 2009, it had been almost 3 years since engineers had been deployed around the world to help address the supply chain problems. And 1.5 years since Boeing missed the delivery date it had originally promised its customers. Finally, in December, a finished Dreamliner was ready for its first flight.
From the time it started as something on a piece of paper to an actual airplane, the amount of work and effort that took to get there, you know, it's 5-6 years sometimes of people's lives that they've put into that one single thing.
You do feel that. I mean, you think it's your airplane, you live, eat, breathe it.
Mike Carricker was the test pilot and had been involved in the design of the plane since the very beginning.
We had great faith in the airplane. A couple of days before, the engine guy, the fuselage guy, the landing gear guy, the brake guy, all these different people got up and said, my part of the airplane is ready to go. And then at the end of the day, the chief project engineer and vice president of division signed the safety of flight letter.
I've covered quite a few first flights in my career. The first flight of the 787 was like nothing else I've experienced.
So exciting! Yay!
Of course, there was this huge air of expectation. The build-up was excruciating, quite honestly.
Main tower, Boeing 001 is ready for departure, runway 34 left.
The culmination of all that pride and ownership that you have, to see the airplane come off the ground, it's one of the most exciting things that you'll ever experience.
It rapturous applause. Everybody was just so relieved to see that airplane get into the sky.
Okay, Jim, setting up, okay, roll on left, Ken.
I rolled the airplane a little left. All the instruments rolled left and the horizon rolled to the left. We climbed to 1-3000 and we went in the clouds. The airplane worked flawlessly. And then we popped out the other side. I'll never forget the picture. In the front left windscreen of the 787 was the snow-capped Olympic Mountains. Just framed. There are 100,000 people in this world right now who would love to be sitting in this seat looking through the snow-capped Olympic Mountains framed in the front left window of a 787. And I got to do it.
On September 25, 2011, more than 3 years behind schedule, Boeing delivered its first Dreamliner to All Nippon Airways. Soon, other airlines began taking delivery of the 787s they had ordered years before, and the plane was finally in service.
When passengers first walk on board a Dreamliner, we literally want them to say, wow. That was actually written in the design brief. That was a goal that we had. A small group of us proposed that we do some work with the flying public around the world.
Does anyone think it's not important?
To get at the deep psychological and emotional needs that people have when they're in this condition of inside an airplane.
You can kind of curl up in.
Try to sleep.
The results of Boeing's research are evident everywhere in the plane's interior design.
They did something with the roof of the cabin so it seemed kind of dome-like. You're entering a really pleasant space rather than the tube.
The window is probably my favorite because there wasn't an airline in the world that asked us to put big windows in the airplane. That absolutely came from our work with potential passengers.
They can control the darkness and lightness with their own fixture. The airlines can cleverly control the lighting in the cabin to influence your circadian rhythm so that you're waking up for breakfast with a sort of glow of a dawn type of light, reaching full daylight levels by the time you land so you feel more awake.
Because the fuselage is composite, it doesn't corrode. Therefore, Boeing can increase the humidity from about 3 and 4% up to 10 and 12%, so you don't dry out.
And because composite is stronger than aluminum, it can withstand a higher pressurization in the cabin. The air inside a 787 mimics an altitude about 2,000 feet lower than a typical airliner, which makes it more comfortable to breathe and travel less tiring.
It's an amazing aeroplane to fly on, and it is the future. It's absolutely the future of aviation.
The 787 has made air travel more efficient for airlines and more convenient for passengers. Because it carries fewer people long distances, routes with lower demand can now be non-stop or point-to-point. London to Austin, Denver to Tokyo, San Francisco to Chengdu, Sydney to Delhi.
The whole argument of hub and spoke is gone. Large jets are simply not in vogue anymore. The point-to-point philosophy basically took over. It was driven by business strategy, technology, and frankly, common sense. People don't want to change at hubs.
As the first 787s entered service, Boeing's bet on a smaller, more efficient plane appeared to have predicted trends in air travel correctly. And Airbus, which had made its bet on a jumbo jet designed to fly people between major hubs, found few airline customers and was facing the possibility it would never fully recoup its investment on the A380.
Airbus may sell 300, they possibly might sell 400, whereas Boeing will sell literally thousands of 787s and make a lot more money.
By the beginning of 2013, 50 Dreamliners were in service, and there were orders for over 800.
We delivered the airplanes that we said we were going to deliver, and we were coming out of the end of the year on a real high. And then we had our first incident in Boston.
Emergency crews rushing to Logan Airport to put out a fire on a jumbo jet.
It's a black eye for Boeing.
We observed a heavy smoke condition, and we found a fire condition in the avionics compartment.
The smoke was traced to a meltdown in the Dreamliner's lithium-ion batteries. Used to provide startup power and emergency backup in flight, lithium-ion batteries are lighter, more efficient, and more powerful than traditional batteries. Boeing was the first commercial plane maker to use lithium-ion batteries on this scale, but now that decision was under attack.
Now we have breaking news from the FAA tonight. They are grounding the Dreamliner.
Just over a year after the 787 had finally entered service, the Federal Aviation Administration grounded the entire fleet.
It's grounded until it can prove to the federal government that the airline has fixed the problem with the battery that continues to overheat.
We had never had an airplane grounded in our history, ever. 50 airplanes in service, and they're all on the ground. We're just getting hammered by the media every day, trashing the airplane, trashing us. It was one of the darkest hours that we had. If we didn't get that airplane fixed, you could lose the company.
What a disaster. You had the top executive, Ray Connor, going to Japan and making apologies and telling people that they were going to fix the problem. And meanwhile, you had the engineers and mechanics working on it non-stop. It was a very high-pressure situation.
The way the team rallied, the commitment that took place 7 days a week, 24 hours a day, it was our finest hour.
Looks like it's coming down around the edges of the thing, then leaking across the bottom. That's probably a current path. So do you think the blue discoloration is affected heating or just...
They switched on every engineer they could find with any ability or knowledge in the area of batteries, and they built what they call a brain farm.
We brought in experts from around the country with respect to lithium-ion batteries, auto guys, we brought people from NASA. We had some experts within the Boeing Company too, because they use an awful lot of lithium batteries in the space world.
So that we can start anticipating, what are the next things that are going to try to set us back.
In the end, we had 10,000, I'm just going to guess, 10,000 people around the world working to get the planes back into service.
Ultimately, we did about 3 years of work in 3 months. We were never able to really establish any single thing that caused it. So what we ended up having to do is look at all the potential things that could have caused it and then put a solution in place to address those.
The solution included wrapping the battery's 8 cells in insulation, enclosing the block in a stainless steel box, and creating a titanium tube through which smoke could vent out of the airplane in the event of a malfunction. Tests showed that the enclosure could contain an explosion, expanding but not breaking. And then engineers created the worst-case scenario.
All cells go off on a fully configured 787, $100 and whatever million airplane, and we had these 2 batteries that we heated up and then had them vent off, and it worked perfectly.
Wind 140 at 4.
In April of 2013, Boeing got the news it needed to hear.
The government will allow airlines to resume flying their Boeing 787s nearly 4 months after they were grounded.
I said we would throw a party, and we threw a party. We threw a heck of a party.
The Dreamliner has become the fastest-selling twin-aisle jet in Boeing's history. The company now has orders for well over 1,000. Enough to sustain at least 7 years of production, and more orders are expected. Enthusiasm for the 787 prompted Airbus to launch its own composite twin-aisle plane. The A350 debuted and became an immediate success. Airbus secured nearly 800 orders, including one from a customer that had flown Boeing planes exclusively for decades.
Japan Airlines' decision to buy Airbus A350 was a big, big blow to Boeing because, part of the reason for all the outsourcing Boeing did was to keep Boeing's hold on certain customers, and then specifically, they had a virtual monopoly in Japan. They've lost it. And they've lost it in part, I think, because of the problems with the 787, because of the delays.
They had somewhat lost a little bit of their faith in us to put all their eggs in our basket, and that was hard. We messed up, and we lost a campaign as a result of it, but we fight very hard. Airbus, they're tough competitors, but I want to beat them.
It took longer and it cost more. We reached too far in too many ways, but sometimes these big game changers are more troubling than you map them out to begin with. But looking back on it, we built exactly the right airplane.
Over its century in business, Boeing has learned that in the high-stakes world of commercial aerospace, risk is unavoidable. Failures are inevitable. Each success is hard-won. And some, like the 787, have changed the way the world travels forever.
They've changed the entire paradigm of aviation with the 787. This is going to be one of the most successful aeroplane programs in history, although it had probably the most traumatic birth